Hello, this is Praveen Tiruvadi. Today I am going to talk about my project which is fog-based moth healthcare using optimized load balancing. So my project objective is in the traditional system of IoT and healthcare, the results are sent to the cloud to processed and this leads to be delay. So the situation in the health related matters are crucial and each second could be something important. So that's why it's the importance of fog computing which is to process close to the patients. This project considers the simulation of such a system and the testing of this effect of implementation of an optimized load balancing algorithm on responsiveness and efficiency. So the system architecture, this slide indicates the entire system applied in the project. It consists of the three layers. The IoT layer has the health sensor to track the real-time data of patients. Such data is then transferred to the fog layer, where local fog nodes are able to process it with an optimized load balancing algorithm. So, in case of anything wrong, alerts are immediately sent to the person's smartphone. The affected information is relayed to cloud layer where information can be kept long term and doctors and hospitals capable of assessing patients' records at any time. Such design causes less delay, energy saving and better real-time answer in health medical care. So tools and technologies. So this simulation was done with the help of Java based simulation toolkit iFogSim. The logic of the main simulation and task placements were performed and the fog nodes was deployed and distributed with task. Two used tools were IntelliJ as the development environment and the text editor to write and run the code. Two fog nodes and IoT devices were used to create a simple test scenario and show how the system behaved and performed with a simplified load. So I'll run my code. So this was my actual code in it was running in main simulations. So we created a application. So we are tracking the device performance while we are sending a information to the cloud. So it will track the device performance here. So I'll here run the code. So this was our result. So it shows the latency, energy consumption, device consumption, and cost of it. So this was the actual results. So we can go to our PPT. So these are the results of the simulations. The mean latency per tuple was approximately 1.1 seconds. And this was reasonable when it comes to real-time warnings. There was a great energy consumptions and in both IoT devices. So given that addressing of the issue is done by the node, most importantly the network traffic was nil and it sustained that tasks were efficiently accomplished back at the fog level. And then key benefits. So optimized load balancing algorithm made sure that the existence of fog nodes was used efficiently so as not be overloaded. This results in decrease of latency and low call-out dependency. So no network bottlenecks were present because everything was processed in the fog. It's a perfect system when it comes to healthcare where the timely response matters. So on conclusion, so this matter has demonstrated that fog computing can indeed be used to enhance the functionality of IoT-based healthcare system to a large extent. So with the optimized load balancing algorithm, the system managed to minimize the delays, decreases the consumption of energy and reduce the amount of money which is spent on the operation of cloud services. So in fact that the data is processed near the connection site made the system faster and more reliable, which is quite significant in scenarios where medical responsible must be timely. So this was my final project. Thank you.